This is Uplash Lab, where we explain complex ideas in a clear visual way. In this video, we will break down how AI understands your questions and generates meaningful answers. You type a question. Seconds later, an AI responds with paragraphs of coherent, intelligent text. It feels like magic. But what's really happening behind that blinking cursor? Let's pop the hood on an AI's brain and discover what's really happening. When you chat with ChatGPT, Claude, or Gemini or any other language models. 1. The illusion of intelligence. When you chat with an AI, it feels smart. It remembers what you said. It understands context. It even catches your jokes. But here's the truth. It's not thinking, not the way you think. Look at this conversation. The AI remembers we're talking about Paris. It connects your follow-up question to the previous context. This looks like understanding, right? But here's what's actually happening. The AI is just predicting the next word, over and over and over. No understanding. No thinking, just incredibly sophisticated pattern matching. It's not a brain. It's not conscious. It's a statistical pattern recognition machine, an incredibly powerful next word predictor. And that's exactly what makes it so useful and so limited. So let's see exactly how this illusion works. Let's follow your words from the moment you hit send. 2. You type a prompt. The journey begins with your words. But the AI doesn't see words the way you do. It sees numbers. You type, explain quantum physics simply. To you, these are words with meaning. But the moment you hit send, something fascinating happens. First step, tokenization. Your sentence gets split into tokens. These are the atomic units the AI actually processes. In this case, we get 4 tokens. But here's the interesting part. Tokens aren't always whole words. The word quantum could be 1 token, or it might be split into quan and tum. It depends on how common the word is. Each token gets converted to a number, a token ID. These IDs are the actual input to the model. So explain becomes 1829. Quantum becomes 31,259, and so on. Your meaningful sentence is now just a list of integers. By tokens instead of words, tokens are efficient. Each one is a single processing step. They're flexible, handling rare words by breaking them into subwords. And they work universally across all languages. On average, 1 token equals about 4 characters. And just like that, ready to enter the model's neural network brain, the translation is complete. 3. The model reads your words. But reading isn't the right word. The model doesn't read linearly like you do. It does something far more powerful. First, let's talk about context. When you're having a conversation, the AI doesn't just see your latest message. It sees everything you've said in this conversation, up to a limit. Here's a conversation about mountains. Notice how the third question says, "It and winter," without specifying what it refers to. But the AI knows you mean Everest, because it sees all the previous messages. This is the context window. But context has limits. GPT 3.5 remembers about 4,000 tokens, roughly 3,000 words. GPT-4 can handle up to 128,000 tokens. Claude can remember up to 200,000 tokens. That's an entire novel. Beyond these limits, the AI starts forgetting your earliest messages. Now here's where it gets really interesting. Attention! This is how the AI actually processes your words. And it's nothing like how humans read. Take this sentence. The cat sat on the mat. When you read it, you go left to right word by word, but the AI looks at all words simultaneously. Let's focus on the word cat. Using attention, the model simultaneously looks at its relationship with every other word. It pays strong attention to sat, because subjects and verbs connect. It also attends to mat because that's where the cat is sitting. This is attention, measuring relevance between words. Each word looks at all other words simultaneously. The model learns which connections matter. This parallel processing is what makes transformers so powerful and so different from how we read. 4. Prediction, not understanding. Here's the most important thing to understand. The AI doesn't know what words mean, it just predicts what comes next. Think about this carefully. The model doesn't know what cat means. It doesn't have a mental image of a furry animal. It just learned that after certain patterns of tokens, certain other patterns usually follow. Let's see this in action. Given the prompt, the sky is, what comes next? The model generates a probability distribution across its entire vocabulary. Blue has the highest probability at 45%. Clear is 18%. Cloudy is 12%. There are actually probabilities for all 50,000 tokens in the vocabulary. Here's the crucial insight. The model doesn't think blue is correct. It doesn't understand that skies are actually blue in reality. It just knows that in its training data, the word blue appeared after sky is billions of times. It's all statistics. This is why AI makes mistakes. It's thinking in probabilities, not truths. It can confidently tell you something completely false if the pattern of words looks probable. Ask it, who was the 45th president of Mars? And it might confidently generate a plausible sounding answer. Mars doesn't have presidents, but the pattern looks right. So the model generates text that fits the pattern. This is called hallucination. The model generates plausible, but false information, because the pattern of words seems probable. It's a fundamental limitation of how these systems work. 5. The magic of generation. So we know it predicts one token at a time. But how does that become paragraphs of coherent text? The process is called autoregressive generation. The model predicts one token, adds it to the sequence, then uses that expanded sequence to predict the next token, over and over. Watch this happen in real time. We start with the prompt. The model predicts photo. Then it sees the prompt plus photo, and predicts synthesis. Then it sees everything so far, and predicts is. Each token depends on all previous tokens. But here's the interesting question. If the model gives probabilities for all possible next tokens, how does it choose? This is where sampling strategies come in. 3D decoding always picks the most likely token. This is consistent but can be repetitive. Temperature sampling adds randomness. Low temperature for focused output. High temperature for creativity. Top P sampling only considers the most probable tokens, balancing creativity with coherence. So why does this simple process create such convincing text? And why does it sometimes fail? Spectacularly, it works because it was trained on billions of examples, learning grammar, style, and reasoning patterns. The attention mechanism captures complex relationships, but it fails because it has no fact-checking, no understanding of truth versus fiction, and limited logical reasoning. It generates what sounds right, not what is right. Token by token, probability by probability, it builds a remarkably convincing illusion of intelligence. 6. Guardrails and safety. Raw language models can be problematic. They might generate harmful, biased, or inappropriate content. So companies add guardrails. Imagine a model trained on the entire internet. It's seen everything: the good, the bad, and the toxic. Without intervention, it might generate harmful instructions, biased statements, or offensive content. It might provide harmful instructions, repeat biased stereotypes from training data, use toxic language, reveal private information, or state misinformation as fact. This is where alignment comes in. Companies use multiple techniques to align models with human values and safety standards. Our LHF involves humans ranking model outputs, teaching it to prefer helpful and harmless responses. Red teaming has experts try to break the model, finding vulnerabilities. Content filtering catches harmful prompts and inappropriate outputs. But alignment is a delicate balance. Too strict, and the model becomes useless. Refusing reasonable requests. Too lenient, and it generates harmful content. This spectrum shows the challenge. On one end, overly restrictive models refuse even benign requests. On the other, too lenient models generate harmful content. The goal is the middle, helpful but safe. Alignment is an ongoing challenge. Models are constantly updated as new issues emerge. It's a cat and mouse game with adversarial users trying to bypass safety measures. Perfect alignment remains an unsolved problem. 7. Why it feels human. Here's the fascinating question. If it's just predicting tokens, why does it feel like you're talking to someone intelligent? The answer lies in human psychology. Our brains are wired to find patterns and assign intention. We're pattern matching machines talking to pattern matching machines. First, anthropomorphism. We naturally attribute human qualities to anything that communicates. Second, we equate linguistic competence with intelligence. The AI sounds smart, so we think it is smart. Third, it maintains conversational context, making it feel like a real conversation. But let's be clear about what it doesn't have. This is crucial for understanding both the capabilities and limitations of AI. It has no consciousness or self-awareness, no beliefs, desires, or goals, no emotions or feelings, no understanding of meaning, just patterns, no memory between conversations, no personal experiences. It's a tool, not a being. Think of it like this. A calculator does math without understanding numbers. An LLM uses language without understanding meaning. Both are incredibly useful tools. The illusion of intelligence doesn't make it less valuable. It makes it more remarkable. 8. Fun experiments. Now that you understand how it works, let's explore some experiments you can try yourself to see these principles in action. These experiments reveal both the capabilities and limitations of language models. Try them yourself. Try ambiguous prompts to test semantic understanding. Give it logic puzzles to see reasoning capabilities. Ask it to count letters in words. It often fails because it sees tokens, not letters. Experiment with prompt engineering. Small changes create big differences. Try creative tasks and watch it combine unexpected. Pro tip: specificity matters. Compare explain quantum physics. Too vague? With explain quantum entanglement. Using everyday analogies much more focused. The model has billions of possible continuations. Your prompt narrows them down. 9. Where it's going next. We've covered how current chatbots work, but the technology is evolving rapidly. Let's peek into the near future. The next generation of AI goes far beyond text. We're seeing multimodal models, real-time reasoning, and personalized assistance. Multimodal understanding lets AI process images, video, and audio. Real-time tool use gives models access to calculators, search engines, and code execution. Agentic AI can plan and execute multi-step tasks autonomously. Personalized assistance learn your preferences, and reasoning models explicitly think before responding. But with these capabilities come significant challenges, technical, ethical, and other questions we must address. Privacy concerns. How do we protect user data? Accountability. Who's responsible for AI mistakes? Misinformation. Combating AI-generated fake content. And access. Will these powerful tools be available to everyone, or increase inequality? These aren't just technical problems, they're societal questions. The future is being written now. Understanding how these systems really work helps you participate in shaping that future responsibly. Finally, it's not magic. It's math. We've journeyed from your typed prompt to the AI's response. Let's recap this remarkable process. At its core, the process is beautifully simple. 3 steps that create the illusion of intelligence. Step 1. Input. Your words become tokens, then numbers. Step 2. Pattern matching. The model uses statistical predictions from training. Step 3. Output. Token by token. It generates a coherent response. That's it. No magic. No consciousness, just incredibly sophisticated mathematics. But simple doesn't mean simplistic. What makes this remarkable is the scale and sophistication. The genius is in the data, trillions of words, the compute, billions of parameters, the architecture, attention mechanisms capturing complex relationships, and the scale, creating emergent capabilities that appear only at massive sizes. So what should you remember from this journey? First, it's prediction, not understanding. The model doesn't know, it predicts patterns. Second, context is everything. What you said before shapes responses. Third, prompting is a skill you can develop. Fourth, it has real limitations. Hallucinations. No fact-checking. Fifth, use it as a tool, not an oracle. Always. Verify important information. Now it's your turn. Armed with this knowledge, you can use AI more effectively, think more critically about its outputs, and participate in conversations about its future. Experiment with different prompts. Think critically about what the AI tells you. Keep learning as this technology rapidly evolves, and share your knowledge responsibly. Remember, behind every AI response are billions of calculations, petabytes of training data, and really clever mathematics. It's not magic. It's human ingenuity at scale. You now understand what happens when you chat with an AI from the moment you hit send to the response appearing on screen. The illusion is revealed, but the wonder remains. Keep exploring, stay curious, and use this powerful technology responsibly. Thank you for joining this journey behind the curtain. If this video helped you, hit the like button and subscribe. It helps more people find these educational topics.